Welcome, my dear students. So today in this lecture, we'll see public key infrastructure. A public key infrastructure, it's called PKI, is set of roles, policies, hardware, software, and procedures needed to create, manage certificates, and manage public key encryption. Means this particular concept, public key infrastructure, is to set roles and policies of hardwares and softwares and the procedures to create, manage and distribute and use and store and even revoke digital certificate. Means total digital certificate management comes under PKI. Okay. The purpose of PKI is to facilitate the secure electronic transfer of information for a range of network activities such as e-commerce, internet banking, and confidential email. Okay. It is required for activities where simple password are an inadequate authentication method and more rigorous proof is required to confirm the identity of the parties involved in the communication and to validate the information being transferred. These are some points of PKI. What is PKI here? In cryptography, a PKI is an arrangement that binds public keys with respective identities of entities like people and organization. The binding is established through a process of re-registration and issuance of certificate at and by certificate authority CA. Okay. Depending on the assurance level of the binding, this may be carried out by an automated process or under human supervision. As in the figure we see, human being is there and then CA is there, RA is there, and they are verifying agent VA is there, and in this way, all hardwares and softwares they are getting under PKI infrastructure. Okay. What are the prominent cryptographic applications where we use? Now, this is the final part of our subject. Authentication and oblique digital signature. We have seen what is digital signature. I'll give you one example of this authentication. For example, if you receive a message from me that I have encrypted with my private key and you are able to decrypt it using my public key, you should feel reasonably certain that the message did in fact come from me. If I think if I think it necessary to keep the message secret, I may encrypt the message with my private key and then with your public key. That way only you can read the message and you will know that this message came from me. The only requirement is that public keys are associated with their users by a trusted manner, for example, a trusted directory. To address this weakness, the standard community has invented an object called a certificate. A certificate contains certificate issuer's name of the subject for whom the certificate is being issued, the public key of the subject, and sometimes stamps. You know, the public key is good because certificate issuer has a certificate too. So this is an example I have taken. Another prominent application area is time stamping. Time stamping is a technique that can certify that a certain electronic document or communication existed or was delivered at a certain time. Time stamping uses an encryption model called a blind signature scheme. Blind signature scheme allows the sender to get a message received by another party without revealing any information about the message to the other party. Timestamping is very similar to sending a registered letter through our postal system, but provides an additional level of proof. It can prove that a recipient received a specific document. That means here we have an acknowledgement system also in timestamping. Once you get the data, you have to acknowledge and you will get an acknowledgement signal also. Okay. Another example is electronic money. The definition of electronic money, also called electronic cash or digital cash, is a term that is still evolving. It includes transaction carried out electronically with a net transfer of funds from one party to another, which may be either debit or credit and can be either anonymous or identified. There are both hardware and software implementations. Anonymous applications do not reveal the identity of the customer and are based on blind signature scheme. Okay, it's very easy. Next point is secure network communication. Now we have already seen SSL, we have seen Kerberos in the previous lecture, so I will not discuss these. The last point is disk encryption. Disk encryption program encrypts your entire hard disk so that you don't have to worry about leaving any traces of unencrypted data on your disk. That means if someone gets access to the computer, then also he will not be able to understand what the data is. So these are some points of encryption and end of unit 2. You can ask me any questions and I will upload this slide presentation also so that you can read it while listening to the lecture. Thank you.